Hello, good people. This is MJ. Today I'm gonna introduce calculus to my fellow students. I'm not gonna say too much, so let's get straight into it. Calculus is not really about complicated formulas. At its heart, calculus is about one simple question: what happens when things change? So I'm saying calculus is the mathematics of things that change. Imagine you are driving a car. Your speed is not necessarily constant. You accelerate, slow down, stop, and accelerate again. Here's the question: how can mathematics describe something that is constantly changing? And here's another one: how can we calculate the total distance we have traveled if your speed keeps changing? These are the kind of questions calculus was built to answer. So precisely, calculus is essentially the maths of change and accumulation. Wait, what makes calculus different? We all know area equals to length times width for a rectangle. We all know 2 plus 3 is equal to 5. But the world is not static. The world does not work like that. A car speed changes, a population changes, a company's profit changes, an investment grows, a ball moves through space. Calculus gives us tools for studying these continuous changes. Everything in calculus comes from two questions. One, how fast is something changing? And the last one, how much has something changed in total? The first question is handled by what is called a derivative. The second one is handled by what is called an integral. So, precisely, calculus is maths that works when things are always changing. One idea that makes all of calculus possible is the limit. A limit is the foundation of calculus. It asks, as x gets closer and closer to some number, what value does the function approach? Notice approach, not necessarily reach. Today we are not going to talk about this. Let's start with studying change. Suppose you have a function describing the position of a car. You might ask, how quickly is the position changing right now? That's essentially asking for the car's instantaneous velocity. This leads us towards the derivative. Derivatives answer the questions on rates of change. For example, the growth rate of a population at a given time, the rate of change of a company's revenue at a given time. So, a derivative is the mathematical tool that calculates the rate of change at any point. With a derivative, you can find how fast is something changing. That is what we call the rate of change. At any exact moment, not on average or approximate, but precisely. That's what you need to hear about derivatives, which are a key to differential calculus. Now let's jump into starting accumulation. Suppose you know the car's velocity at every moment. You could ask, how much distance did the car travel altogether? You are literally accumulating lots of tiny pieces of distance That's the intuition behind integration. Like we said, the question is handled by integrals. For example, the total cost of a company over a time period, the population change over a time period given. So to say it out loud, an integral is the mathematical tool that calculates accumulation. Here is something beautiful about calculus. Differentiation and integration are essentially opposites or reverse processes, and this deep relationship is formalized by the fundamental theorem of calculus. We are not going to talk about this today. Now you have heard this, let's talk about this. Why should anyone care about calculus? Calculus appears in physics, economics, finance, actuarial modeling, engineering, and computer science. Calculus is not just another chapter in maths textbook. It's a language for describing how quantities behave when they changed. Here's what you will learn in our next series. And remember, we are not gonna rush through this. We are gonna build calculus from the ground up. First, we will understand ideas. Then we will learn the maths behind those ideas. And finally, we apply to real problems. Thanks for watching. Yours, MJ.